Good evening. My name is Bernhard Janischowsky, Managing Partner of Trestle Group, the sponsor of tonight's event. Me and my colleagues Sishan and Tom are extremely excited to welcome all of you to tonight's discussion on artificial intelligence in risk management. As financial advisors in the banking industry, we believe that the way we are doing business in banks will change. Digital transformation will not only impact human behavior, but also create new opportunities for the way we are conducting business. Artificial, augmented intelligence will enable innovations that make banking processes more efficient, more effective, and less risky. And it will enable decision makers to embrace upon new challenges and new business model that will lead us in the banking future. As consultants, we believe in empowering innovators in creating the future of financial industry. We are extremely excited and looking forward to tonight's discussion. And with that, I can introduce to you tonight's panel: Grace Brasington from IBM, Frank Luijckx from 4th-IR, Martin Moeller from Microsoft, and McNeill from Google.
So let me try and tell you a little bit about how this might work in a space where you have old and new technologies. So think about a world in which we only want to distinguish between borrowers based on two attributes: FICO score, which is like a credit score, and income. And let's assume we have an old technology, which is like a linear technology. Okay? So in this world, I might say anybody who has FICO and income above this particular line over here is a good credit, and anyone who has FICO and income below this line is a poor credit. And now think about a new world in which we have access to this fancy new nonlinear technology, which has this shape here, where the decision boundary is actually in this kind of L shape. Okay, so this is like a machine learning scoring method, for example. And what happens here is that, now suddenly all of these people sort of look, kind of less risky under the new technology than under the old technology. But there's a group of people who lose out by the application of the new technology. And you can start to see this here. Okay? So when the new technology comes in and we have access to this new machine learning method, maybe suddenly our black box algorithm tells us that the truly risky people are sort of all below these blue lines here, and the less risky people are above these lines here. And so what happens is you're going to clearly have some new people who are winners, but some people who are losers when the new technology comes in. Because obviously here, these losers used to be considered less risky under the old technology, but are below the blue lines and are considered more risky under the new technology. Why is this interesting? Because if we think about, minority groups and majority groups in population, say we divide them by race or by gender or by things like that, and we find, for example, that the minority group sort of is sitting over here and has FICO scores and income levels that are around here, whereas the majority group is over here. What happens when you introduce this new technology is it looks like minorities lose out and majorities win in terms of their credit scores. Okay, so this is kind of an interesting aspect, and I think more and more people are starting to think about this, where we have these unusual social science aspects that we need to think about, distributional implications of new technology, risks that we might not have thought about before that suddenly become apparent. And so this is the sort of thing that we need to be doing more of, which is thinking about the way that society is going to evolve as a result of our new technologies. It may be that we have more efficient risk prediction tools at our disposal, but suddenly these new technologies are opening up potentially more and different risks. So I'd like to encourage you in today's presentations, which are terrific, of course, and panel discussions, to sort of expand these definitions and think really carefully about how AI is going to affect our society and to think about the risks that might be involved.
Thank you everybody for coming to this evening. Thank you for Imperial College and Trestle Group for co-hosting this event and help organise everything. The Institute of Risk Management is the leading body for advancing the profession of risk management. We are involved in qualifications that are globally recognised. We do research. We also set standards for competencies in risk management. And we have recently, in fact, as recent as last week, just launched our new qualification of International Certificate of Risk Management and Financial Services. So you would have seen some information around that, about that and around. We also have what we call regional interest groups and special interest groups. And this particular event has been organised by our banking, well actually Enterprise Risk Management in Financial Services and Banking Special Interest Group. And we have been quite active. We run quarterly events. We have had previous sessions on fintech, risk appetite, and I must say this is very, very well attended tonight. In fact, I think it's one of our biggest attended events. And so what I'm going to do is I'm not going to go on for too long. I'm going to introduce you to the chair of our financial services SIG, Raza Sadiq, who are then going to introduce the speakers. Thank you very much and enjoy the event.
We are very honored to have with us basically Grace Brasington from IBM, who's flown in from Jacksonville, Florida, Frank Luijckx from 4th-IR, and Martin Moeller from Microsoft, and of course Matt McNeill from Google. What an amazing panel. I couldn't have asked for anything more. My focus today is all about artificial intelligence and how it impacts risk management as a profession, how it impacts industrial sectors, be it financial services or the healthcare, it doesn't matter. But the industry, it's a much bigger question. And I think the questions, hopefully, that I get today from the audience, or we get from the audience, will be of that nature. So I'll field the questions. Hope that works for everybody. Yes? I'm going to say, accept that as a yes. And now we'll move on to introducing Grace Brasington, who is from IBM. Thank you so much, Grace.
So let's get started. How many of you have knowledge of artificial intelligence, machine learning, or cognitive systems? Raise your hand. Good number. So there's the first few slides I'm going to go through very quickly because this audience understands it. Many of you already understand it. But I like to start with this slide because the reality of today is that companies are facing disruption. And they come to us and they come to the other technology companies and they say, I'm drowning in the data. I have too much of the data. How can I use information more effectively? And one of the key things they're saying more and more now is, an app is disintermediating me. And if we think about Airbnb, and we think of these technology companies that have come into play, and how they are disintermediating us from an industry perspective, disruption is an opportunity. It can be an opportunity for those that use information effectively. And recently, we had a top 4 automotive CEO in our facility in New York, and we asked him what his biggest concern was. And he said, from a competition perspective, it isn't the other car manufacturers, it's Uber. Because his concern is, in large cities, people don't want to own a car. And nowadays, we have to think less about the driving experience and more about the passenger experience. How can we give the passengers the best experience at the lowest cost? And that is the nature of what we're dealing with in terms of this industry. Today, it's all about immediacy. It's all about click. I want my car. I want it now. In banking, I've been in banking for a long time, most of my professional career. And I remember the days when people said, oh, it's all going to be digital. There's not going to be a need for a branch anymore. That's not true. It's all about the ATM, it's all about the branch, it's all about the call center, and it's about digital. We want it however we want it, whenever we want it, and we should get it that way. And this is the environment that we're in. So, you know, one of the examples from a risk management standpoint on what we're seeing at IBM and in other companies is this need. And I look at the private wealth space, the affluent market. What do I want in my investment advisor? I want someone who knows me. I want to be able to opt in and have them take a look at what's going on with me from a social media standpoint. I want to be linked with them. I want them to know what's going on in my life. Why? Because the more they know about me, the better advice they can give me. My daughter's about to graduate from college, theoretically. She'll be off the payroll in April, but who knows? I've got another one who's a sophomore. But in any event, he knows how to talk to me. I want him to advise me. I want him to use the information and to see from a risk perspective what risks I want to take on so that I can do business that way. I want to know what others are doing. I want to know what other returns are. But at the end of the day, I'm going to pick. And that is the essence of where we are from an overall industry standpoint. Now, I was in banking. I was a former chief compliance officer. I joined IBM about 18 months ago. And one of the issues I had in compliance and in risk management was data. I had data. We were awash with data. 90% of the world's data was created in the last 2 years. 90% of the world's data was created in the last 2 years. 80% of it is unstructured, dark data. It's the voice, it's the email, it's the text, it's the blogs. And 70% is the rate of increase that we're seeing in financial services every single year. 70% increase in data. So the issue isn't data. It's how do we take the data and translate into information that we can use from a competitive advantage perspective. How can we use the data to do a better job from a risk management perspective? So when we look at the environment that we're in today, we've got pervasive interconnectivity. I mean, look at the power of our cell phones. That's a power of a computer years ago. We're always connected all the time. I do a lot of travel. I see people on their phones all the time. We have an explosion of data. By 2025, 180 zettabytes of data. And our view is data is the source of competitive advantage. The more you know about your customers, the more you can transact with them, the better the situation is. So data is the natural reservoir that we have. And being able to use that data more effectively and more efficiently by using some of the artificial intelligence or cognitive technologies is key. Now, when I joined IBM 18 months ago, I have 2 girls, they didn't really know what I did. She's some vice president, she has a lot of conference calls, she goes to meetings, she's traveling a lot. But then 60 Minutes did an expose about Watson and what we're doing in the cognitive space. And in that broadcast, we talked about how we started from a Watson perspective. And what we did was we ingested research papers, medical research papers, and we leveraged that to transform how we're doing cancer treatments today from an oncology standpoint. We took the best of the best in Memorial Sloan Kettering, and we took the MRI images and the X-rays and fed it into the system, and we took all these research papers and diagnostic reports, and we said, okay, let's see how we do. And oncology is a tough business, and the Memorial Sloan Kettering oncologist said, nah, I don't think so. Skeptical. I don't blame them. But the reality was, when we had done that, and they looked at cases that Watson identified, and their best of the best oncologists, we were spot on in terms of the approach and the diagnosis. Where we were different, in 30% of the cases, was in treatment options. Because Watson identified new research that the best of the best of oncologists in Memorial Sloan Kettering missed. Why? Because there's so much data out there. And so to the extent we can use that data more effectively, that is the ultimate value proposition. So I look at it, I say, well, there's machine learning and statistical analysis, there's artificial intelligence, and then there's cognitive. And we do believe, from a world perspective, that every decision that mankind makes in the future is going to be informed by some cognitive system or technology, and that the world is going to be better for it. Think about what we were able to do with Memorial Sloan Kettering. Now, what if we could apply that same type of technology to third world countries who don't have a chance at finding a good oncologist? We're fortunate. You're in London. I'm in the United States. We've got some great technology capabilities, the best of the best in terms of hospitals, but other places don't have it. So these systems have the ability to understand, to reason, and to learn. And while humans excel at imagination and they have the ethics and the compassion, cognitive systems have the ability to locate the knowledge and the information and to use the natural language capability to be able to inform us. What are we doing? Give me some practical use cases, Grace. Talked about what we were doing in the private wealth side. But in risk and compliance, we're seeing these technologies being used as it relates to AML, KYC, know your customer. The more I know my customer, the more business I can do with them. And oh, by the way, I have to from a risk management standpoint. using it for conduct risk purposes in terms of surveillance technology, and we're using it in the regulatory compliance space to be able to merge between risk and compliance and the control infrastructure and the new regs and policies and procedures. These are real capabilities that our clients are enjoying today. And at the end of the day, clients, data, we basically protect. IBM is a company that transacts with other companies. But we will touch a billion consumers by the end of the year in terms of Watson through the business customers that we have relationships with. So our view is clients have the choice and control over their data. If you're going to use your data to train these systems, it has to be yours. That's your competitive differentiation. That's your natural reservoir. And we're going to use domain expertise in this process. So who are training these systems should be a question that everybody should be asking. How am I getting this information? Who's doing the training? And this is where, from an IBM standpoint, we've made acquisitions in the risk management space because we said, we got to merge what's going on from a regulatory perspective, we've got to merge in terms of what's happening from a client perspective, and we've got to take the technology and integrate those three things together, because one by itself isn't going to get us to where we need to go from an overall industry standpoint. We think this is transformational. I think you do too, because you wouldn't be here. Your time is precious too. And we do believe that there is going to be a new paradigm relative to new collar jobs. So before we had blue collar, white collar, new collar, where you don't have to have a 4-year degree, but maybe a 2-year degree, where we can transform what we're doing from risk administration and the manual processes that exist today to true risk management. I want to end with this case study. I had the privilege to sit in on some of the engineers' meetings, and we talked about the importance of working together. And we have established a partnership on AI best practices with the best of the best. IBM, we can't do it all by ourselves. We're going to partner with the Microsofts, with the Amazons, and the Googles of the world, because at the end of the day, we have to do things in a way that's ethical. All the technology in the world, the best, man and machine, woman and machine, it is together. It is all about augmenting intelligence, not displacing it. So with that, I'll turn it over to my next speaker, Frank.
Thank you very much. I must say I feel like a kid in the candy store, or maybe a Lego land or something like that. You know, somewhere in 1976, I started playing around with this stuff, and I better push on the button, right? Okay, here we go. Somewhere in 1976, I started to play around with artificial intelligence. I mean, many of you in the room were probably not born by then, but yes, we had computers and we were able to do something with that. And ever since, I've been working on this stuff. And today, now, I mean, maybe for a couple of years now, all of a sudden, it's all available. It's out there. You can start working with it. And when you can start working with it and start combining it with the use cases, when you start seeing what humanity needs, then you get really, really enthusiastic about it. And that's why we formed the 4th-IR company. 4th-IR, Fourth Industrial Revolution. So with a bunch of guys, we decided that we really need to do is take that tremendous opportunity of having all these components available, whether it's IBM, whether it's Microsoft, whether it's Google, I mean, and probably another 500 others. They get smaller as you go down the list, obviously. You know, you can bring it all together and you can start building things with this. So the time is now. I'm excited about it. My partners are excited about it. 4th-IR is excited about it. We believe that you can leverage this emerging science of artificial intelligence, call it cognitive computing, call it machine intelligence, whatever name you give it, deep learning. You can leverage it to make the world a safer, more sustainable, but also a more productive place. And we can do that by building practical solutions that are easy to understand and simple to use. So we don't want to argue with a complex solution. We want to make sure we deliver something that is understandable. So the time has come, and I would suggest that you invest now to be a leader, or as far as I'm concerned, you can also pay later to be a follower, but that could be a little bit more expensive, so warn you for that. Now, I hear a lot of concern about, well, human intelligence, will computers ever replace humans, etc. Well, look at on this screen here. That's humans for you. And I'm not going to say that humans are flawed in general, but, you know, Deepwater Horizon, what, you know, the rig out there in the Gulf, somebody said, yeah, I know, but I'm going to take the risk. Well, thank you very much. You know, you took a risk. You know, think about German wings. You know, you think that if, and I'm sorry I'm going to say it, if you would have used IBM Watson Personality Insights and would have tracked every email from every pilot, there wouldn't have been a red flag that this guy was a little bit emotional and unstable. So that is unavoidable. Personally, I worked on a project a couple of years ago on healthcare-acquired infections in hospitals. It's a bit of a controversial topic, but roughly between 200 and 350 people die every day in the United States alone of infections they acquire in the hospital. So applying artificial intelligence to improve that, if you only improve it by 10%, you save 25 lives a day. I'm just going to take the low number. So yes, humans are somewhat flawed and there is opportunity. However, at 4th-IR, we do believe that it's the symbiotic combination of human intelligence and artificial intelligence that is going to bring the breakthrough. It's not one replacing the other. Now, this is a human. Credit goes to my partner, Thomas, here. He's a bit obsessed with Homer, so he insisted that his slides get in here. I'm not going to go why, but so we believe, you look at this, that systems, machines, whatever you want to call them, can actually see better today. They can hear better. They can definitely read better. I mean, Grace just told you. The thing can read millions of documents in the blink of an eye. It can certainly reason almost as good as a human. If you put all that technology together, making sense out of that, all that input, it's pretty darn good when you start working with it. And, you know, we did depict the brain a little bit smaller of this artificial intelligence system, but it's all there. Now, what the human brings to that, and it's a controversial thing, is the human biases. I mean, a lot of financial people in here, and I know none of you do this, but I normally, when I make profit in the stock market, I sell too fast. And when I'm losing, I never sell until, you know, I really have to sell, right? So that's a clear cognitive bias. There are some books out there that describe 120 different cognitive biases that people have. One of them I would recommend is You're Not as Smart as You Think You Are. It's a very interesting book to read. Or another book, it's, you know, Predictably Irrational. That means we're very predictable, although we're very irrational. Good book to read. And then, of course, The Invisible Gorilla is always a classic, right? Where, you know, there's so many things we don't see. So you got to deal with that as you deal with people. So, let's move on. Wanted to talk about some of the examples. Now, our company, 4th-IR, has been working on healthcare so far. So the three things we've really delivered on so far are biopsies, you know, understanding biopsy slides, interpreting them, and we scored pretty nicely there. I mean, we came in 15th on a list of 450 participants, and I may say, I didn't see Imperial College on that list, but there were some notaries like MIT and Harvard and Heidelberg and AC Anderson on there. And they were in our neighborhood, so we're quite proud of that. As I said, I worked on the healthcare-acquired infections, which we were able to identify some very hot spots in the hospital where infections were being hosted. And we now just delivered a system for open heart surgery readmission. And those are very successful. They all save patients' lives. And they actually save money, so that's always a very important part of it. Now, what about risk management? I think I've heard Grace say it already. Data It grows, it is dark, it is incomplete, it's ambiguous, it's a mess, but don't worry, because if you don't like yesterday's data, you're going to have more tomorrow. So if you start working on making it better today, then you will have better data tomorrow to work with. What would I do if I were to be in risk management? I would start collecting in a big data lake. Martin can help you with that. You know, perfect place to put it. You know, apply probabilistic and deterministic analytics to it. Don't forget the old stuff, but start applying the new stuff. Cognitive computing, natural language processing, all of that kind of stuff, machine learning. But then also use tools to link it back to the human being. Here's an example of such a tool, Panama Papers. Go to the website, interesting thing to browse through. And that's it. So 4th-IR, we do believe that the symbiotic relationship between human intelligence and artificial intelligence can lead to great things. Thank you very much.
Right, so now I'm going to introduce Martin Moeller from Microsoft. After Martin, it'll be Matt McNeill from Google. All right, guys.
Buddy. Thank you very much. First and foremost, everybody can hear me? Yes, no, maybe? Fantastic. I'll sum up. Yes, 10 minutes to tell you what is Microsoft doing in the AI space. It's a challenge. I'll try to rise to it. First and foremost, artificial intelligence. Actually, we do call it slightly different. It's augmented intelligence. Now, when I entered Microsoft, I thought, okay, great. It's funny, bullshit, bingo, PR. It isn't actually. I was very impressed when I came in, and it wasn't so long ago, to find out that anything and everything we do around AI is clustered around those 4 ones. I don't have a Homer Simpson, but it would have worked as well here. So it's about see, speak, hear, and understand. And actually, this is truly about the augmentation. So if you need another pair of hands, how do you get it? This is it. If you need 100 million hands, if you need 100 million eyes, this is the idea behind it. It's not about competing with humans. It's not about replacing humans. It's about the augmentation of it. Because today we have so many tasks, we have so much to do, and we heard a lot of different areas already from Frank where we can massively improve. We do need this augmentation to master today's complexity. Of course, these are very interesting words, and it looks nice, but it's a bit of abstract thing. So I want to take at least a couple of minutes to go into what do we really understand this and give a couple of examples. When it comes to seeing, Microsoft doesn't build any self-driving cars. Nope. But we do, of course, work with all the major car companies in the world in terms of helping them get there. And seeing is an absolutely essential thing there. Is this a kid running across the street, or is it just a plastic bag being blown across the street? There's not a minor distinction, it's actually a major one. And of course, later when we talk about the ethics of AI, when you have an AI deciding, should the AI also be held accountable? If you have to brake to avoid hitting the kid, but that might actually, with an 80% probability, endanger the 5 people in the car, what do you do? These are all the key things that go to it, and without seeing, you can't decide. Now, speaking and hearing, actually, we have an annual company event. This year it was in lovely Las Vegas, so we had good fun, but we did a bit of work. And being old and boring, I had no idea who this guy is. Apparently, he's a big pop star in Asia. And they invited him on stage and did a live rap battle or rhyme battle, however you want to call it, with Zoe, one of our AIs. It was actually very, very fun to watch. Him rapping in the microphone, she coming back. It was very good entertainment. But it's not just good fun. When we really want to take augmented intelligence seriously, we need to be able to actually interact with machines. And we've heard it a couple of times, natural language processing, as abstract as it seems, it's absolutely essential. Machines need to be able to hear us, we need to be able to hear them, so they need to be able to speak back. It's a key thing if you do want to take augmented rather than artificial intelligence seriously. Now, the last one, the understanding one, this is one of my favorite examples, really. We're all in banking here, so obviously it's about how can we make more money, how can we have less cost, and PTI goes up. But this is one of the examples where AI actually has a real impact on people's life and making it better. And the lady with the red hair, actually I think she's based out of London. She's a creative director, she's a designer, and unfortunately when she was around 29, she got Parkinson's. Now I didn't know really much about Parkinson's, but I read myself into this case a bit. Ultimately it goes back to your brain sending out signals over signals over signals that basically are becoming a vicious circle, and they overload your nervous system. And that's how you get these tremors, these Parkinson's tremors. You can imagine if you are a designer and you suddenly can't write your name anymore. That's rather dramatic. And the lady on the right-hand side, she's based out of our AI research lab in Cambridge, and she came across this as well, and she started tinkering a bit. She said, look, if we can actually understand how these kind of brain waves, these kind of interactions come to be, can we not then also change this? And she was sitting tinkering, and if you go and just Google the Microsoft Emma Watch, you also see videos of it sitting in a London apartment, building what eventually became the Emma Watch. And what it did is, actually, it analyzes these different brain waves, these patterns in the brain, and you wear this watch, it emits a pulse into your hand, and ultimately shortcuts this vicious circle of the brain waves overloading the nervous system. And you can see what happened from the left-hand side top there. That was Emma actually writing something without the watch on. On the right-hand side, you can see it with the Emma Watch on. And for me, this is just a fantastic example of AI is not just about finance and banking as much as we're all bankers here. It's about something that can really, really help people. Now, we are, after all, in an AI in risk management event today, so pattern recognition is something that then also goes into machine learning for finance and risk. One of the key things I think we all know about is stopping fraud. Fraud is a massive problem for everything in finance industry, from identity theft to you name it. And here it goes on to what are the patterns of your usual behavior? How do people usually interact? Goes on to also misconduct. What do they usually trade? Do they trade low values, high values? We all can detect these patterns in an Excel. That's no problem. We can do this. But if you actually have to do it at scale, around millions, 100 millions of data points, that is very, very tricky. And here, pattern recognition, machine learning for AI, for risk, that comes into its own. We're working with customers not only detecting more fraud than before, but actually taking it down from minutes into seconds of detecting it. Another thing is, of course, biometric security. I think this morning I read in the Financial Times that the SEC in New York was actually hacked. So security is a key element of our digital future for us personally, but also for institutions. Security, making your own institution's cybersecurity 100% safe is key to managing risk. You'll never be 100%, but where we are now is not where we should be. And this is a lovely, easy example of actually the way we use a trackpad on a computer is just as unique as is our fingerprint. And these are just extra examples of people using trackpads on their laptops. And I can also here detect the patterns. How does somebody usually interact with their device? And suddenly if somebody is a bot trying to do an attack on your computer, on your system, they will be completely different. If I use the scroll pad on your computer, I will be different from you. So here again, cybersecurity, and these are very simple solutions, make a massive difference when it comes to managing the risk in your institution. Last but not least, we need to look into the future, and they're working with all the big insurances in this world. We just had the hurricane season, and Grace can actually tell you the first-hand tale, being from Florida in the US. So here, massive amounts of data. You cannot imagine the huge amount of data that goes into these kind of systems. Data lake, we already heard it. And how do you get all this data? How do you put it together? Garbage in, garbage out. You actually need to really work with that data also to then find out when is the likelihood the highest that something is going to happen, not just to save lives, but also, again, we're in risk management, to manage this, to manage the impact from the insurance industry to the reinsurance industry to how do we rebuild the country or how do we rebuild Puerto Rico later on, going into the finance industry. And those are just a couple of examples, and I don't actually see who's supposed to give me the time. Up there, 2 minutes, fantastic. I can give time back because I managed then to give you a brief overview of what Microsoft is doing in the AI machine learning space right now in 8 minutes. I'm very happy. I hope you halfway enjoyed it, and I'm looking forward to having a really good debate later on when we go into the Q&A. And now, Matt from Google.
Well, welcome everyone. I'm Matt McNeill. I think I've got one of the best jobs in Google. And my 10-minute introduction is just to give you an explanation of why I think that's the case. I work in a part of Google which really represents Google's infrastructure. And really, where does that infrastructure come from is an interesting question. So 19 years ago, last week, the simplest web page on the web launched. And between now and then, in order to drive this page, an immense amount of R&D has been executed over the last 19 years. So to serve you searches and cat videos or whatever else you consume from Google is actually some of the world's largest infrastructure. This is a picture of one of our data center halls. It's actually one of many on that particular campus. That campus forms one of a cluster of about 3 campuses which serve population groups of about 500 million people. When you do a search, you're searching an index of about 100 petabytes, that sort of order, and getting a result back in under 200 milliseconds. And in order to give you the best result possible, machine learning is operating within that window at that sort of scale. Now, that's forced us over the last few years, actually the last decades, to really drive thinking about how we work with data. So I think Grace said earlier, data is the rocket fuel which you need to be able to start things like machine learning. This is a picture of some of our latest racks, actually, if you want to geek out on them. These are what we call, well, they're actually custom chips. We call them tensor processing units. And for those people in machine learning, we sort of outsourced probably, or open sourced a few months ago, or years ago, something called TensorFlow, which is how we do machine learning at scale internally. These racks are between sort of 11, probably those ones on the picture there, between 11 and 12 petaflops of processing power. That's sort of supercomputer range. And they're full of custom chips purely to process machine learning. Now, that's quite a lot of investment. We invest probably about 10 billion a year in some of this infrastructure. Behind this, as I mentioned, we have this track record of publishing open papers. So I've just picked a few out here on the data processing side to illustrate this. Some of the papers we were publishing 15 years ago, which led to some of the core tools you'll find in a big data space like Hadoop, which allow you to start working with data. What my job is, and why it's interesting, is I get to work with the bowels of Google's infrastructure and R&D in this geekery. And about 5 years ago, I was in a room with about 20 or 30 other people debating whether we should make these available to people. Fortunately, we did, and we now have 4,000 or 5,000 people working on this. So all of those are now available, and what my job is to take them out to people and figure out what we can do with them. Because here's the thing, we don't always know. We know how it works in our environment, but we don't necessarily know what innovation is going to come out by deploying it into your environment. So that's the fun I get to have, working with people like HSBC, for example, in the finance industry at the moment. Now, machine learning is a core thing. It's probably one of our number one priorities at the moment, and that's simply because we've got to a stage, we believe technically, where we can start doing machine learning at a scale which makes it really feasible. Machine learning and the techniques that we're using aren't particularly new. They've been in the technology space, if you've done degrees in computer science, probably for 2, 3, or 4 decades. The whole area of artificial intelligence, by the way, is much bigger than just machine learning, but machine learning is where I think a lot of the advances have been made recently. This is our CEO, Sundar Pichai, and when he talks about this, about 18 months ago, our entire company pivoted. So when you look at our product stacks, this is a pull from some of our source code directories of how many products we're launching today which have machine learning as a core part of what they're doing. So our translation systems, for example, moved recently onto machine learning platforms. When you're using your Android phone to ask it questions, or Google Home, you're using machine learning models. Some of the more interesting areas is what we're doing with DeepMind. How many people here have heard of AlphaGo and the... So what really staggered me was this fact here. The AlphaGo board, 19 by 19 board, has 10 to the power of 172 combinations. Now, that sounds like a big number, but just how big is that? The number of atoms in the universe is about 10 to the power of 80. So what it says is this is a class of problem which, unlike chess, which can be brute forced, you simply cannot brute force this sort of game. It's why we picked it. We wanted to see whether we could get something which could recognize the aesthetics and the patterns within a board like this in order to win. Because you simply can't calculate the best outcome. You've got to feel it. And so these technologies are starting to make, really the techniques, it's starting to make technology in a way more humane rather than just rational. Now that does lead to a lot of ethical questions, a lot of societal questions, which I hope we're going to dig into a little bit on the panel later. We also have been doing some very interesting learning on the cutting edge. This is another piece of work by DeepMind. And it's where we're starting to move from what we call supervised learning into unsupervised learning. So what happens when you start building deep neural networks or machine learning systems where you're not giving it the answers to train on? You're just giving it the data. So in this example, we were building systems without telling them how to walk or showing them how to walk, seeing if they could figure out themselves how to walk. So self-learning. And this is a key area as we move into unsupervised learning territory, which becomes very, very interesting because of some of the biases that you sometimes get within the data sets, that we bring perspectives to the data and to the answers that machine learning algorithms can find. We started applying this internally. Let's make it concrete. We applied a machine learning algorithm to our data center operations. We've got a lot of smart people in our data center. They didn't think we'd be able to find something that more optimal than they already figured out over the last 10 years. 40% reduction. And by the way, we spend a lot on data center cooling. So this translates to, how should we say, multi-millions of dollars every month in savings. And what you start seeing is here's a multivariate problem, hundreds of different variables being optimized, not maybe once a week by some expert human beings, but once every 30 seconds by something that's even more expert. And so you can start doing things you really couldn't have imagined before. On the other end of the spectrum, they're getting applied to our systems. So, for example, Inbox, one of our email systems, we launched this auto-reply. So a bit like spam filtering checks your email for spam to get rid of, what this was doing is saying, this email looks like it's going to generate a response. Actually, we can give you the top 3 likely responses. And what we found is, after launch, within probably a couple of months, 10% of email responses using the system were using auto-replies. And for those of you that are managers, this is exactly the sort of thing. No one could tell the difference. It works really well. So the way we kind of been thinking about this and externalizing these systems, particularly on the machine learning side. By the way, in Google, machine learning is just part of our infrastructure. All of that work is done within our infrastructure teams. So we have this concept of infrastructure that goes very deep. But as I mentioned earlier, we open source through TensorFlow our machine learning systems. They're available. You can run them on your laptop if you want to. But what we've also done is started looking at all the models we've already trained. So take Google Photos with the Vision API, or when you do an image search on Google, that's a machine learning problem. Understanding what's in that image, being able to identify it. When you do translation, recognize speech, analyzing text, sentiment analysis, all of these are tractable via machine learning. Now, we already have some excellent models in that space. So on one level, we've just been making those directly available as part of this offering. And that's been driving some really interesting work from some of our customers that we're working with. Here are a couple of examples. This was a very small province called Kiribati. They control actually quite a bit of sea, but they don't necessarily have a big GDP, as you'll see at the bottom. What they were finding was that their seas were being overfished and abused. They couldn't track who was legally transiting the ocean and who was doing a bit of cheeky fishing on the side. So by applying machine learning, you can tell this is a trawler. This has got these sorts of nets. And they started making fines which accounted almost for 1% of their GDP, which is quite fun. Buy or sell. Descartes Labs started forecasting US corn production. They got it in under 2% in terms of the accuracy there. It enabled them to predict ahead 5 months ahead of what the official results were. When you're a corn trader, which is what they are, that's a pretty big competitive advantage, which was fascinating. On the insurance side, we're doing a bunch of work with AXA. I think 0.1% of the cases generally produce sort of returns, or I should say payments of over 10K. Identifying those is obviously critical when you think about the volumes of cases. We were using the TensorFlow models with these guys and started getting an 80% prediction rate accuracy of drivers who are likely to be making those sorts of claims or whether those claims would pay out, and huge reductions in costs that came from that. One of the more interesting ones we did was with the USAA. So these guys, we've been partnering with them, taking the image APIs that we have and allowing them to extend it to be very, very specific to their domain and use case. In this case, being able to take a picture of a car and recognize which bits of the car are likely to be damaged and how badly damaged. So that, as an assessor, you just take a few pictures, And almost in real time, you can start getting assessments back as to whether this is a likely payout or not. And this maybe costs them a couple of $100 a month to run, but maybe 1 million times that in terms of operational savings. And that's the sort of examples of problems that you can solve with machine learning, which I think can really change the game for a lot of companies. For us, I had a nice picture here of Larry Page, which obviously I forgot to paste in. So I'll skip that one. Oh, there we are. So Larry Page made this statement with Charlie Rose a couple of years ago, which I think really encapsulates the way we think about this massive change in technology that we're facing today. We are in a generational shift of technology paradigms, probably something we haven't seen for 30 or 40 years. The opportunity is huge. What we worry about almost all the time is, are we going to miss the future? And I think these days, everyone's a technology company. This is a bit of advice every single one of us can take to heart. So with that, I think I'm going to stop, and maybe Raza will move on to the panel. Thank you.
So I'm now going to go directly into our first question to everybody. Are you ready? Yes. All right. How risk management, do you think, will be transformed through artificial intelligence? Question to all of you. Whoever wants to start first.
I'll start first, if that's okay. So we look at risk management and we see opportunities in multiple ways. Again, I talked about it, moving from risk administration to risk management. And one of the things that we have focused on from an investment perspective is taking some of our Watson capabilities and incorporating it. And the first area, and you alluded to it, is in the know your customer area. To the extent we can improve that client onboard process, that's beneficial from an overall industry perspective. And using some of the cognitive and the machine learning capabilities to onboard clients more efficiently and more effectively, but also to make sure that we're assigning the right risk rating associated with those clients. Because if you get the risk rating wrong, it feeds into your transaction monitoring system and it just generates a bunch of alerts. The second area is in the AML space in terms of the alert monitoring and the triage process. Because, again, 98% of what we're seeing from an alert perspective is false positives. So, again, to the extent we can use some of the cognitive capabilities and look at, prior history, prior work that had been done, that's of huge value. And then generating the dossiers associated with what would be filed from a SAR perspective. Again, that's an area of focus. So AML, KYC, you had talked about what's going on from a fraud standpoint and payments. We're very focused on that. But the other area is around surveillance insight. And the reality is that the regulators are concerned about market abuse and what is happening from a control infrastructure standpoint as it relates to monitoring activities. And so one of the things that we've really focused on at IBM is basically looking at voice data, electronic communications in terms of email, and using some of our APIs associated with that, along with chat rooms. And in my prior life, when I was the CCO, whenever I had concerns around a particular employee, let's say they downloaded information, too much MPI, red flag, then all of a sudden we would launch an investigation. How can you bring the data together more effectively? And that's where we're going from an overall surveillance and conduct risk standpoint so that we can identify anomalies in advance. So we can look at the HR data and say, yes, this person didn't get a bonus. All of a sudden, their email correspondence, and again through APIs, went from a happy person to an angry person, right? And all of a sudden in chat rooms, they're complaining about their boss. And leverage that information not to make the decisions, because it is about augmenting intelligence. It's not about displacing it, but using that data and providing that to the compliance professionals in the first line and the second line of defense to say, here's the information that we have, so that they can decision whether it's an issue or not an issue. And then in the last area around regulatory compliance. This is a huge area because depending on what research paper you're looking at, we're seeing between 20 to 40,000 regulatory changes that are occurring in a given year. There's no way any compliance organization can keep up with that amount of change. And so what we see as an opportunity is merging what happens in the reg change space, the 20 to 40,000 regulatory changes, and 300 million pages of regulatory documentation by the end of 2020, policies and procedures, and controls. And we're incorporating our cognitive capabilities as part of the GRC infrastructure, so that where I've got my policies and procedures and my controls and my walkthroughs and my testing and my assessment process merging with the reg change, so that at some point in the future, we can look at the real-time monitoring of what's going on from an overall compliance perspective. Because we have to get to a point where we've got sustainability and compliance, and we've got to move from the swivel chair effect that we see in AML KYC, where we're looking at system, swivel chair associated with surveillance, swivel chair in terms of reg change, and really use these technologies to inform risk managers more effectively.
Would you not say that by using swivel, what was the swivel thing?
The swivel chair
That's
effect.
it, the swivel chair. If you don't...
And you get whiplash
well,
after
absolutely.
a while.
Well, if you do the swivel chair, clearly your conversation or the narrative will be very clunky as well.
Correct.
So you're not able to be, you're more known as a police function as opposed to a
Part of the business.
required function.
Exactly.
Well, it's
Right.
part of the business. There actually question, who here is actively working in risk management? Wow. So who of those that, keep your hands up, let's do a bit of workout. Who of you guys thinks that you're the best friends of your frontline organization? Who thinks they love you?
Sometimes.
And I think that's actually going to be...
Well, wannabe probably, not really.
Yeah, I love you all, of course, but I think that's going to be one of the biggest changes here. You can be the best guys you are, but if the organization doesn't actually work with you, if they see you as this police guy, if they work against you, you're not going to get anywhere. You're always going to have to run after them. You're going to get crappy data because they think, oh no, yet another tool to fill out. I just do it 5 minutes, you don't get the right data, all of these kind of things. And here actually, when you come to having all the technology in your company with compliance and risk management built in, that's why I think AI and ML come to their own in these kind of things. So imagine somebody who goes to customer meeting and says, well, I'm going to go to a customer meeting, put in my Outlook and say, I'm going to talk to somebody in Germany about alternative finance. Well, there is a couple of regulation attached to that. Usually they would have to go to your whatever portal it is, find the regulation, find out, oh yes, reverse solicitation, that is something. If this comes automatically, wouldn't that be wonderful? If things are being actually automatically pre-filled, if you actually become the friend of your frontline organization, you don't have to run after the data. It actually becomes something that is more or less convenient for them to do. They're helping. This is where the tools come in, where they can get a lot of stuff done for you. You have to do less. Your organization has to do less. And actually, you don't have to hide from them anymore when you see them in the cafeteria. I think that's going to be one of the biggest changes coming.
But Martin, my view on that is, when I was a CCO or a CRO, I wasn't going to be their best friend, but they needed to know I was watching. And these types of technology capabilities enable you to let them know that you're watching, because then they come clean quicker.
Absolutely.
They do. I mean, that's the reality. And the other thing I would say is it just isn't about technology. It also has to be about the people that are training these systems. So, about when I first joined IBM 18 months ago, we did not have subject matter resources at scale that we needed to train these systems. And that was one of the reasons that we acquired Promontory. 600 people that had regulatory compliance background and practitioners. Because if you are only looking at it from a technology perspective, yes, and the customers don't have any patience. I mean, I didn't have any patience. Just put the fire out and move on to the next fire. We are in that professional juggling situation right now. So leveraging people, the practitioners that have the experience that used to be former regulators with customers and technology company, I think is the way we've got to do this, because it can't just be about technology.
So it is technology and translating that technology to ask the right questions.
Domain expertise.
Be aware of what's going on before it happens, potentially.
Proactive compliance.
At least look at some patterns. And the other thing, as both of you alluded to, is you can't be their friend, but at least by asking the right questions, they realize that they need to be your friend.
They need to come clean.
Right. Become a friend.
I'm a bit more of a trusting person, you can tell.
I would like to jump in and take a little bit of a different position. I mean, it's a bit of my role on the panel, I think I have, right? And that's not contrary to that, but whenever you have a new tool and a new capability, in this case artificial intelligence, it also gives you new possibilities. So you're going to have the ability to assume new risks, and you also have the responsibility to understand your customers and the technology they use so that you can judge that risk much better. Let me give you an example.
Yeah.
And it's a classic example. I know when a jet fighter goes up, particularly an F-22 or an F-35, that thing is not flown by the pilot. The pilot is along for the ride. He gives the general directions. But the artificial intelligence in that machine flies that airplane.
Absolutely.
And you could never fly that without the algorithms. And I would say that in the future you're going to have companies that can go on the business edge, on the business, take that business envelope to the edge because they have the ability to predict, they have the ability to deeper understand, and you have to understand that as a risk manager so that you can facilitate that.
Facilitation, yeah. Well, absolutely. Which is very similar to what everybody's saying, which is exactly what is the narrative. You've got to change the narrative so that it flows as opposed to it becomes clunky and swivels. Yeah. Anything else you want to add, Matt?
I think I agree very much with the comments that have been made around the sort of the processes that we really face today with regard to what we're managing risks for.
Yeah.
But I was reading that question slightly differently, or there's another way of reading the question, is what risks will we have to manage when AI is democratized? That's an interesting question. When you think that anyone that you might be worried about could themselves be using AI. Because it doesn't take a lot to
Are
go
you going
and start
into
using
Blade
this
Runner territory sort of thing?
Well, no, I think that, with any new technology, there's no magic bullets really within this. There's kind of a bit of a question because a really significant technology changes the environment itself that it's operating in.
Yes, absolutely.
And, what we're talking about when we're looking at risk management is actually understanding the nature of the changes, not just in its micro sense of the individual processes, but in the macro sense of what risks we'll be looking at and facing. And we mentioned that the organization, actually many of us on the panel here, our companies are subscribing to, is a recognition of the fact that these technologies do have significant impact, which are related to our social values and what we believe to be acceptable and how they should be thought of and regulated potentially. So I think that's where the questions come in, which is sort of the next derivative really of this broader question. And I think where understanding these technologies, what they're going to be doing, will be a process of exploration that we all have to engage in.
This is so interesting. So what you're saying, sorry if I just want to understand this a little better. So what you're thinking is potentially we have risk registers. In a lot of financial companies, we are used to risk registers. So what you're saying is potentially a lot more clustering of risks around more key risks, which are a combination of very other risks.
I'm saying that there could be risks that aren't on the register.
Right. Completely.
Because
we don't even know what they are.
Entire categories of understanding what the interaction of these technologies with society is, or with people's behaviour. And as I say, these technologies are not going to be something that is limited to large companies with high capex. The whole of the technology revolution has been around a key thing, which is the fact that 20 years ago, the ability to deploy capital was a competitive advantage that kept people out of your business areas. Fortunately, finance has regulatory, which helps, and maintains the competitive advantage to keep people out, notwithstanding fintech and everything else that's coming through. But these days, it's the opposite. There are companies starting up which don't need capital at all. And the fact that you're deploying capital on a 5-year cycle or a 10-year cycle is not an advantage to you, because they're not. They are operating on a 6-month cycle. They're moving faster, they're innovating faster. And I think when you look at the impact of how that dynamic plays out in this sort of environment, that's where it becomes fascinating, is to understand what these actually small companies are doing in this space for and against. And I think that's actually some of the most
That's the
interesting
real thing.
aspects of this question.
Absolutely, so we don't know.
Well, we don't.
And the other thing, which is what Grace started out with, was the Airbnb being the largest
Yeah,
was
I
it?
mean, the hotel accommodation.
accommodation company without having any real estate at all. So
It's the same.
both of you are saying exactly, oh, fantastic, okay. Right, sorry, going to the next question, perfect timing to the next question, which is how is artificial intelligence, decision-making and human bias, basically looking at the two things, and what are the ethical implications? I think this alludes to the question that was asked by yourself, Nika, is that right? So that's the question to the panel. Do you want me to repeat it again? Are we good?
No,
Ethical
we're good.
implications of AI decision-making, I guess. That's the question.
I'll let you go first because you had an opinion about that.
Well, I mean, I think this is an area where we all have to work together. But we trade, and the question was asked, privacy for convenience every single day. Every time, we order an Uber car, we're telling them exactly where we are, right? I mean, so we do it. But we have to look at some of the ethical considerations. I was in New York City was when I first started with IBM, and we were with some of the best in medicine, some of the car manufacturers, and we said we have to work together from an overall industry standpoint relative to the ethical considerations, which is why we reached out to the Microsofts and the Googles of the world, because at the end of the day, it's what are we doing with this technology, how can it be used, and how can we use it for good? And I do believe that this has an opportunity to transform how we're doing things from an overall risk management perspective in terms of mitigating risk and making processes that were manual and resource intensive more efficient and effective. But I also think that there's some economic benefits in terms of being able to make more money, because the more we know about our customers, the better client experience we give, the more apt they are to continue to work with us. So I think the good outweighs any of the negatives. I also believe that it's about augmenting, going back where Martin and I are totally in alignment. And it also has to be about transparency. One of the earlier presentations was about a black box. If a black box for credit scoring, I don't believe in black boxes. I don't believe in black boxes. If these systems are one big black box and there's no transparency associated with it and no audit trail and no ability to know how certain decisions were made, that is not where we need to be from an industry standpoint. It has to be about transparency. It has to be about audit trail, because in my space in financial services as it related to risk management, how did you get to that decision? The regulators would ask.
Can you justify it?
You have to be able to.
Absolutely. Now, just a question to Martin on the back of that. Why is there so much media hype about the fact that, the ethics are not being accounted for in the big companies?
Is there that much media hype that we don't account for it?
That's what the media
Let's take
says.
the hypothesis, yes, there is.
Yes.
Firstly, it's not so.
I'm saying there is.
We are actually, and you've seen it, we're not enemies, we can actually be friends, and especially on these type of questions, we do need to work together. I can't explain the media hype.
I understand.
Not going to go into a whole
Fake news.
All right. Somebody had to say it. The other was the American.
It had to be the American. The cab driver brought it up to me whenever I was in the cab on the way to the hotel.
So not going to go into all of that, but
that.
it's one of those things, we do see it coming. And we don't want to have an Oppenheimer effect where we look back and see, I would have never thought this came out of it, because this is not something that's going to be a one-off event. It's going to be exactly like you said, redefining industries, redefining society, redefining how we actually consume information, which is the basis of everything we're doing, not just in risk management. And there are just 2 points for me very important here. The one is we've seen, I don't know, I think the lecturer left at the beginning here, this lovely diagram about where could we go when we have different credit scoring and if we overlay this with different societal patterns. I'm not going to take an opinion on this, but this is exactly the debate we need to have. What, however, if we open this up, if we take regulators, we already see it in financial modeling, FRTB was mentioned at some beginning, they go into models. How should we model things? And they're not going to stop looking into just financial models. They're going to start actually auditing and looking into different AI models. And we already have these discussions where they want to see, like, open the black box, and this becomes difficult when you look into neural networks. But these discussions are happening. But what's the next step? If we say, well, we don't like this social outcome, we always have this mantra in AI machine learning, let the data speak, which is absolutely correct. But what if we don't like what the data is saying? So we're going to go and tweak the data. There was a lovely quote, if you torture data enough, it's going to confess to anything. We can do that. Or we can simply overrule. And we had a lot of events in history, starting from financial crisis very recently, going all the way back in Frank's presentation. There were a lot of examples there where actually humans overruled. And we might think this is for the social good, and this is a valid debate to have. I can't have an answer, but these are the debates we need to have. If we overrule, if we step in, is this actually going to help? Is it not going to just introduce another bias? And this actually leads to the second point that is very important for me here. We've got big companies sitting here, and it's very easy to say, especially in finance, well, let the big companies do it, or let the regulator do it. But this is one of those debates, irrespective of banking and finance, anything AI, machine learning, where the responsibility goes out to everyone. Because it's not just about what we do with it. For better or worse, we're living in capitalism, and we are driven by what the customers want. So suddenly people start saying, well, we want this AI and that AI, do everything for us. Just make us automatons that do whatever my smartphone tells me. Well, this is not for us to decide. This is where everybody in society needs to say, how far do we want this to go? How much data do we want to give? We can't wait for regulators, Google, Microsoft, IBM to solve this. So these are the things where it's good to have these events.
Well, absolutely, and you're thinking about it. That's the big thing. You know, to have the three of you, four of you to talk about it and thinking about it.
Yes.
It clearly indicates that it's not.
Put the 5 biggest brains in a room from all the companies doesn't get as much as putting everybody in one room and getting actually that interaction.
I think you've answered my question. At least the hype is, in my opinion, now a hype. That's what I think. Anyways, that's my opinion. Matt, Frank, do you want to add to that in terms of ethics coming from healthcare or?
Well, you know, definitely in healthcare, it's a big thing, obviously. I mean, if you take a risk and you lose money, it's a big thing. If you take a risk and you lose a life, that's a bigger thing. I mean, let's be very clear about that. But I would also like to say that, you know, as a great philosopher once said, let's not be afraid of the world we made. And that was Billy Idol in one of his, It's Hot in the Summer and all that. Right, but it's, you know, listen, I mean, we're at Imperial College here.
Yep.
Science is going to progress. Science cannot be stopped. This stuff is coming, so we need to take this responsibility and deal with it. And take the right steps and do it. You got to also realize that your world is already completely governed by this stuff. I mean, there is so much out there. I mean, chemical plants were run by this kind of stuff 40 years, or no, maybe 25 years ago. You know, the intelligence in there that says, don't do that because it's going to go boom. The engineers program that in. They don't let an operator make that decision. So we need to go with that, but it's got to be a combination of the human intelligence and the artificial intelligence. You've heard that over and over again. That's my point.
Thank you. Thank you. Matt.
So, I think this, when you look at a machine, I mean, we talk about AI first, and you ask about the sort of how people think about it and how it relates to society. I'd say of all the technologies that we've seen in recent years, AI probably has the most mythical aspect to it. And what do I mean by that? I mean that within our culture and our psyche, the idea of the robot, the Terminator, or it's
Runner.
deep. It goes Blade Runner is another one. You can trace these kind of myths of autonomy back 2,500 years to Greek times. It's really this founding idea of what happens when we build something more intelligent than we are. So when we're talking about artificial intelligence machine learning, you've got to recognize there's a mythical dimension to this, on which we pin hopes or fears. Now, if we reduce that back a little bit and look at what's actually going on in the area of machine learning, and then within that, there's two real areas. There's those supervised model developments where what the AI trains on is data that was given and decisions that were made. And the ethics of that AI and its moral compass is really based on the training set that it's provided with.
Absolutely.
Now, it sort of gets a little bit more interesting when we look at the idea of accountability. So, how many people here have been on a jet plane transatlantic or around Europe recently? Yeah, great. How much work do you think the average pilot does? these days.
Hardly.
And has done for years. It's almost all autopilots and has been for a long, long time. But we always have a pilot. In fact, no, we have two pilots
co-pilot
there.
and engineer.
And the reason for that is actually the dilemma of accountability. How do we explain our actions and stand by them? And I think this is a fascinating area. The DeepMind guys actually published some papers a couple of months ago about being able to look inside neural networks and have them explain themselves. And what's driving that is a lot of work they're actually doing in the healthcare area, that they're doing in financial regulatory areas, where you have a model that needs to explain its decision and give the reasons why. And I think that's going to be a massive area of research over the coming years, because it feeds into these critical aspects of accountability and turning what could be seen as a black box into a white box. And if you want to track some cutting-edge research, these are the sort of areas which are fascinating right now.
Wow. So like patterns potentially to identify cancers, better oncologists, which you were referring to as well.
Mm-hmm. Better
Grace.
risk management, more efficiency, more effectiveness. But going back to the credit risk example also, banks have fair and responsible banking departments, fair and responsible lending departments. So if people are going to be potentially pushed out, they're looking at those things from a statistical perspective and saying, this would not be appropriate. I mean, in corporate compliance organizations and in first line of defense, that exists. So there are controls in place to mitigate some of those concerns associated with what's being brought up.
Thank you. Wow, thanks a lot. Okay, so the final question for the panel. Can AI rewrite black swan theory?
No.
Right.
I'm done.
You're done? All right.
Well, Frank, do you want to expand on that?
I want to not take your time. I mean, black swans are what they are, right? I mean, they are called black swans. They're described by Nicola in his book and quite extensively, and why you should think about them. And what we have done, honestly, is we've called everything that was a surprise a black swan.
Yes.
Now, just because you're blind and you don't see something doesn't make it a black swan.
Right.
So a lot of those will go away as we have better forecasting. I would point towards the book Anti-Fragile, which actually deals with dealing with the black swans, and I would say that AI is beautifully aligned with that. I will leave it at that.
Well, I'll actually just second that. I think we have a lot more grey swans than black swans, to be perfectly honest. And we had a couple of these things, companies coming to us and saying, we missed the past 5 years of trends. And there was food industry, there wasn't anything in finance. And today, with the data we have, and you showed the graphic, and you showed it on the appliances multiplying, and you multiply those two together, and then you have a completely overwhelming store of data. We took all of that data in, we looked at it, we got the 5 trends right on the back, we gave one to the front, they sent the team out there to investigate. It was a $50 billion market missed in the US at the moment. To your point, it wasn't a black swan. It's just that today, when we do this augmentation right, we have so many eyes, so many ears, more than we used to have before. But things that are just completely unpredictable, where to your point of the, I think it was Abilene, the airplane accident where the pilot did have the history of mental troubles and mental problems. Not for everything data exists, and we will never get those away. But I think today, as you said, we're calling so many grey swans black and hide behind that, and well, we could just not have known. I could not have known that there was a rogue trader doing a lot of hundreds and thousands of trades that it was just impossible to know. We don't have this excuse anymore with the technology, with the data we have. So we'll see a lot less, but the theory, I believe, still stands.
Right, but can you sort of, I know you won't want to say this, but can we move towards saying that we need to get less colorblind or become more colorblind? Which way you want to go, I don't know, but basically, is it really relevant anymore? Really, in the grand scheme of things?
Black swans?
Yes.
What do you think about Fukushima, Elon Musk, and fracking did to the energy industry?
Still does.
Those are 3 real black swans. How are you going to predict those with artificial intelligence? But you can get resilience built
I'm going back to what Matt said, which is it learns. You're learning with the deep dive that you're talking about, that it's actually happening, isn't it?
Not on defense.
Well, it gives a different sense. I still think you won't get away from them being that. I really don't think we're going to get this. Actually, to your point, we might rather see a couple of new black swans. We had our own learning experience when we put AI bots out there, and suddenly they behaved in ways that were neither. See, yeah, some people know it. They were neither expected nor were they decent, and we took them off again. You don't know. You have to just learn to fail fast with these things as you do in a startup environment. But in any case, I don't think we're going to get rid of black swans. I don't know when you ask about whether it's relevant. Has it ever been relevant? Us accepting that there are things we can't control, that it's just accepting it and be done with it.
Right.
But I do believe we need to take seriously that we can do much better than we do today, and we need to be prepared for things to come out of what we're doing today that might actually come back to bite us in the bum.
And
Sorry for my
become
French.
more deterministic from what I learned from Matt today. In terms of our modeling, it'll be less probabilistic and more deterministic. Who said that? Somebody said that. So it is a bit more definitive, potentially.
I was at a large technology company who processed about 60% of the mortgages in the United States. And we watched people, consumers, using their home equity loans to buy dinner. We saw it. We all saw it.
We knew it coming.
We knew it was coming.
But did we do anything?
When you look at the home prices continuing to go up and the fact that income was not at a sustainable rate to match up with what was happening, and the prices continuing to appreciate, and people using the ATM or the home as a piggy bank relative to refinance, 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 take the cash out, take the cash out, take the cash out, we knew what was going to happen. And a few people bet against the market, and they made a tremendous amount of money.
Did very well.
But most people did not see it coming because of the bias, because prices are going to continue to go up, and they can continue to go refi, and it'll be okay. And then it wasn't.
I mean, I think Grace makes a key point there, actually.
Absolutely.
You know, if everyone actually remembers the real story behind the black swan and why it's called this, you know, the term black swan was invented in the 16th century or something like that. And it was invented and used to talk about something which was everyone agreed was impossible, because there was no such thing as a black swan.
Yeah.
Until they sailed to the New World and found some. And, you know, the motif really is that we make assumptions about stuff that we think are absolutely true, but they're not. And that's what catches us out. So when you think about when we're training models or we're training systems, we're implicitly making assumptions that we're not accounting for. So there's a very interesting way of looking at this is a paper I read probably 18 months ago, and it was talking about different kinds of uncertainty. And it laid them out in this way. You know, the stochastic uncertainty, you can apply analytics, you can apply algorithms to those, statistics to those, and you'll get bell curves and everything else, and you can treat stochastic uncertainty, probability. But he says that's a very different order of uncertainty to the next category, which is systems. So as soon as you get very complex multidimensional systems, you can't treat them stochastically. There's too many variables, and actually you don't get right answers because the inputs you make to a system affect the system and affect its behavior. And so you see that in natural systems, you see that in large complex systems. And actually, machine learning can start addressing those problems as a technique, because it has this adaptive quality and can take multiple variants. But the third category is when you've got people on the other end. And this is where the bias comes in, because, you know, as Grace says, it's very hard to convince someone of something when their salary depends on not understanding it. Yeah? And if what you've got on the other side of that risk is someone who's actively trying to understand what you're doing and frustrate it, and you make the mistake of thinking it's a different category of uncertainty, you're done. They've got you. And so when you think about everything from military tactics and military situations, you've got to be really careful about what sort of uncertainty is actually at the other end of it. Otherwise, you're dead. So we've just got to be careful, I think, of not trying to believe this is going to be a silver bullet for everything. It won't be. People are intelligent, they're creative, they understand what you're doing, and they're going to play poker with you.
Thank you so much. Thank you very much, panel. It's great. Thank you.